What's up, everybody? Welcome back. Another rate of change word problem. So a diver's height above the water, ht in meters, t seconds after jumping off a cliff is modeled by h of t is equal to 36 plus 2t minus 4.9t squared. What is the speed of the diver when they enter the water? So we've done a couple of questions like this. So let's first show what is happening on a graph. So we got height versus time, right? That's the equation that we were working with. The diver jumps off a cliff. So notice if we plug in 0 for the time, for t, we'll end up with 36. So they're jumping off a cliff that is 36 meters high. Notice how this is a parabola, so the shape is going to be something like that. And on this diagram, when are they going to enter the water? Well, they're going to enter the water when the height above the water is 0. So basically the x-axis represents the water. So they're going to enter the water here, and they want the speed of the diver when they enter the water. Well, notice how this is a height versus time graph, right? A displacement versus time graph. And the speed of a displacement versus time graph at any point in time is always what? The slope of the tangent. So we got to find the slope of the tangent right here at that point, right? So the slope of the tangent at that point on this parabola. Well, we first have to find out at what time that point is happening. So we have to find out this time t. Notice we don't know when the diver is going to hit the water. So the first step is we have to figure out when is the diver hitting the water. And we can do that with this equation. We can plug in 0 for h, because notice how h is going to have a value of 0 at that point. So we can have 0 equals 36 plus 2t minus 4.9t squared. And notice how we have this quadratic equation. And because we have this decimal here, not really going to be able to factor that. So we're going to have to use the quadratic formula, unfortunately. Right? So what's the a value going to be in this quadratic? Well, notice it's going to be the coefficient that's in front of the t squared, so it's going to be this negative 4.9. The b value is going to be this 2. Actually, you know what? Let's write it in list form just to not get confused here. So b is equal to 2, and then the c value is going to be this 36. So usually quadratics are arranged where we have the a, b, and c. Here it's arranged a little differently, so don't get confused when you're inputting your coefficients in the quadratic formula, right? The a value is negative 4.9, b value is 2, c value is 36. And then when you do the quadratic formula with these inputs here, you would end up getting two answers. T would be negative 2.51 or t is 2.92. Notice time can't be negative, so we would ignore that answer. So the diver is hitting the water at 2.92 seconds, right? So now that we have the time at which the diver is hitting the water, we have to find the slope of the tangent at that point, or the instantaneous rate of change at that point. Now there's a couple of ways to find this instantaneous rate of change at this t value, but let's find the most exact speed. So we're going to have to use the difference quotient. It's going to be a lot of work because we're working with a lot of decimals. There's 4.9, 2.92, but let's do it anyway. So the instantaneous rate of change is going to be what? It's going to be h of 2.92 plus h minus h of 2.92 all over h. Okay, there's a lot of h's actually happening here. So this h and this h is different. This h here represents the height. So you know what? Let's, for now, for finding this instantaneous rate of change, just to not get confused with this h and this h, they are different. Let's say the displacement versus time. So this h here, let's call it d of 2.92 plus h minus d of 2.92. right? So I just changed this to another letter just to not get confused with the h's in the difference quotient and the h's of the equation that we were given. So what you got to do here is you have to plug in 2.92 plus h for all the t values in this equation. So you would end up with 36 plus 2 times 2.92 plus h minus 4.9 times 2.92 plus h squared. Right? And then d of 2.92, notice how that's just going to be 0 because the height is 0 at that time. So we're going to have minus 0 at the end, so we don't even have to write that. And then this is going to be all over h. So we basically have to simplify this, which is going to be a headache because of all these decimals that we're going to be working with. So further simplifying this, 36, then this 2 will distribute inside the bracket. We'd end up with 5.84 plus 2h minus 4.9, and then this 2.92 plus h squared. We would end up, if we FOIL that out, 8.5264 plus 5.84h plus h squared, and that's still going to be all over h. So let's continue this up here. I'm going to erase this part just to give ourselves some more room. Okay, so this 36 plus 5.84, that would give us, what, 41.84 plus 2h, and now we have to distribute this negative 4.9 inside the bracket into those three terms. And when we do that, we would end up with negative 41.77936 minus negative 28.62h minus 4.9h squared. And actually, unfortunately, I haven't shown it in this example, but this and this should be equal. The reason why they're not equal is because we've been rounding a little bit too much. But if we didn't round, if we kept everything to all of their decimal places, both of these things would equal, they would cancel out, right? The numbers always cancel out. Basically, your numerator in the difference quotient has to be all in terms of h's. So these two should be the same. So let's just pretend like they are. They cancel out. Then we have 2h minus 28.62h, which would give us negative 26.62h minus 4.9h squared. And that's still going to be all over h. So now what we can do is we can factor out an h from the numerator. So when we do that, we end up with that bracket. This is going to be all over h. The h's cancel out. So we're left with negative 26.62 minus 4.9h. Since we're finding the instantaneous rate of change, we want the h to be very small. So what happens as h goes towards 0, well, that whole portion will go away, and we would just be left with negative 26.62. And if we round that, approximately negative 27 meters per second. So that is the slope of the tangent there. It's negative 27. The reason why it's negative is because it's negatively sloped, right? The height is decreasing. So because they're asking for the speed, we would take the absolute value of that. So the speed at which the diver is hitting the water is approximately 27 meters per second if we round. So notice how the difference quotient is a bit of a headache when you're dealing with these decimals here. Another thing you could do is you can do like preceding and following intervals, or maybe the centered interval method, like the squeeze method. But yeah, either way, you should be getting something very close to 27 meters per second. That's the final answer.